Howdy howdy. Today we are going to look at three files in olly and we're going to see how they compare to C++ code. If we run it, we see it print some stuff and that's it. And they all do the same thing. Let's look at the first one in olly. Analyze. Okay, so we know compiled programs with dev C++, at least, you can go to the first actual internal call and then go to the call just before the exit and that'll take you to your code. And here we are. So we see a loop that prints 1 to the screen. Looks like oops, 9 times. So let's put a breakpoint here and we'll find out. We'll hit run. That's going to move to EBP -4 0. And it's going to compare that number with 8. JG, jump if greater, is testing to see if our byte, our number at this address is greater than 8. If it is, it'll jump here. It's not, so it's going to push 1. It's actually moving it to the top of the stack, but it could push it. And then it's going to call printf, which is going to display it on the screen. Now it's moving to EAX, the address EBP -4, and now it's going to increment the D word at EAX. If we follow that in the dump, we see it's 0, and now it's 1. Now it's going to loop. And it's going to test if it's greater again. And this continues until the number is greater. Okay, so in C++, what is that? Well, here's the actual program. And that is the same as a for loop saying I equals 0 while I is less than 9. Do this loop, and each time add 1 to I, increment I. Okay. Then we see another loop that does 2. And it says compare with 9, jump if greater. So is that the only difference? Looks like it. So we're going to print one more 2 than we did once. And in assembly, it's just going to say, okay, is it greater than 9? In C++, it looks like this. If it's greater than or equal to 9, or less than or equal to 9, continue. And as we see up here, it's less than 9, but in assembly, it tests against 8 and jumps if it's greater. Here, it's going to test against actually 9 and jump if it's greater, which is the same as, is it less than or equal to 9? Okay, now we see one that moves 9 to the D word at EBP -4. It compares it with 0. It jumps to here if it is less than or equal to, and it prints 3s on the screen. In C++, that looks like this. Int I equals 9, while I is greater than 0, I minus minus. Okay, and now we have the same thing, but it's JS. Okay, what does that mean? Help on command. Jump if sign. If flag S sign is 1, jumps to the instruction at address. Okay. So if this flag here is 1 after this compare, okay, well why would it be? Help on command. Compares contents of 32-bit memory at location EBP-4 with the immediate constant 0 and sets flags O, S, Z, A, C, and P according to the result. The flags are set exactly in the same way as for sub EBP 0, but EBP-4 is not modified. Comparison is usually followed by conditional jump or conditional move. So instead of jumping if equal, we're jumping if sign. So if these end up being equal, this is going to be 1, and then this will jump. And here we have that as I equals 9 while I is greater than or equal to 0, I minus minus. So once this goes to a negative, which is less than 0, it's going to jump out. Let's watch that one. So let's follow and dump that memory address. And we see it moves 9 there. It decrements it. All right, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, compares it with 0. It's not less than. So it's going to do it one more time. And now it's -1. It compares it with 0. And we notice the S flag is now 1. So it's going to jump out. Let's look at the next one. Okay, so this says move 0 into the address, our counting address, compare it against 8, jump if it's greater. So once we're at greater than 8, which is 9, we're going to jump out. This is the same as saying continue as long as I is less than 9. Let's see if that's true. Oh, it's a while loop. A equals 0, while A is less than 9, printf 5, and then increment A. But this is a while loop, and our first one was a for loop, and they look identical. So we can learn from that in C, a while loop and a for loop compile down to the exact same assembly code. So let's look at the next one. So now this one is just like our second for loop, and it is going to continue printing 6 as long as we are less than or equal to 9, because we're only going to jump if we're greater than 9 and less than or equal to 9. The next one is move 9, compare against 0, jump if less than or equal. So if it's less than 0 or equal to 0, we're going to jump, which is the same as saying continue doing it as long as you are greater than 0. And it's decrement B, decrement B. We continue on with the JS, so once the sign changes, so once we go negative, which is going to be less than 0, we're going to jump. So that's continue while we're greater than or equal to 0. Greater than or equal to 0. Okay, now this one looks a little bit different. This is testing at the end, and it's doing this stuff first. It's move 0 into, we'll call it I, push the string 9, print it to the screen, move the address of EBP minus 4 into EAX, increment what's at that address, compare EBP minus 4, what's at the address EBP minus 4 with 8, jump if greater. So it's going to continue to do this stuff as long as we are less than or equal to 8. And the reason it looks different is because this is a do-while loop. It tests at the end. So this is going to be printed while it's less than 9, which is the same as less than or equal to 8. So we're going to go jumping out if we're greater than 8. This is a do-while loop. Again, you see it test at the end, so this stuff gets done before there's even a test. So if this was already 10, this stuff would get done until it got down here and went, oh, we need to jump out. It would always get ran at least once. That's why you use a do-while loop. This is what it looks like in assembly. So it's going to move into, we'll call it again, I0, and print the character, or the string 10 onto the screen, move to EAX, EBP minus 4, increment it, compare it with 9, and if it's greater, jump out. So now we are doing things. We're going to do this loop while we are less than or equal to 9. And let's see, less than or equal to 9. And I think there's 2 more. Okay. So this next one is a do-while where we start with 9 and we de-increment and we compare against 0 and we jump if we're less than or equal to 0. So it's going to continue to do that while we are greater than 0. Continue doing it while you're greater than 0. This one, once the sign changes, so it's going to be greater than or equal to 0. We start at 9, we de-increment each count. Once we hit negative, we're going to jump out. If we're already, let's put a breakpoint here, run, and let's move there, -1. Let's undo that. Do this. Okay, we have room. Okay, so we're less than or equal to 0, but this is all going to get ran once because it's a do-while. It does everything while the test is still true. So even if it's not true on the first one, it got ran. Our 12 is there. Now it's going to jump out because we're already at -1. And that right here is greater than or equal to 0. So in this video, I just wanted to kind of show the comparison between the C code and the assembly code. But you might have noticed there's a couple more executables on my desktop. We're going to open another one. We're going to leave this one open. We're going to scroll back up. And the only difference between this one and this one is I compiled it with optimization and only optimize more. So let's look at that in olly. Now, we notice right off the bat that the loops look a bit different. This one is way bigger than this one, so it is optimized. Now let's read one of these. Move to EBX. So now we're using a register instead of an actual memory location. 0. So we're going to move to EBX 0. Then we're going to move to dword local 6, which is ESP 31, which is 1. So now instead of storing the string 1 somewhere and pushing the address like we were here, we're just moving the character and calling printf. So let's hit F9, and here we will watch that. Moves 1, then we're going to call this little fancy sub that was made to print it onto the screen. If we hit F8, we see our 1 shows up. It increments EBX, compares EBX against 8. It jumps back to the beginning if it's less than or equal to 8. Okay, so instead of comparing at the beginning and jumping out if we're false, so this is greater than, testing if our number is greater than or equal to, or greater than 8, and if it is, jumping out. This is jump if less than or equal to 8 back up to the top. And if we look back at our code, the very beginning, less than 9. So this is saying compare it against 8. If it's less than or equal to 8, go back to the top, which is the same as comparing against 9 and doing jump if less. Just how the compiler wanted to define it. Now, the rest of these are about the same. This one starts at 9 and it decrements and it tests EBX, and that's going to be true if they're both 0. EBX, if EBX is 0, and it will continue as long as it is not 0. This here decrements EBX and jump if not sign. So as soon as EBX goes negative, it will not jump and it will continue on. Let's watch that one. So we start at 9, decrement to 8, it's jumping, doing its loop. We're at 5, 4, 3, 2, 1, decrement, 0, decrement, FF, and now we're not jumping. Now, that one was number 4. And again, we're not pushing strings, we're just pushing a character and writing it to the screen. So the next one is a while loop, and as you can see against this number 5, it's much smaller. And again, we see the compare at the bottom, and it looks exactly the same as the for loop. So those compile to the same assembly code. Now, let's look at the do while, which the first one is number 9. So that would be right here. Well, we notice that nothing's really changed from this do while and this while loop. Because we've been testing at the end every time. So what we can infer from this is, with this optimization, we don't do a test at the beginning ever, and this code can always be ran at least once. if we were to start here and not here, because if you start here, EBX is going to be set to 0. But if you were able to start here and EBX was already something like not 8, this is all going to get ran at least once. But it is quicker and it saves a lot of space. And the rest of these look about the same. The only difference is less than 0 decrement EBX, jump if not signed. And we did see that before. And test EBX is going to be true if it is 0. And then we see press enter to exit. And so let's scroll back up to the top here and look at one more file. We'll open that in olly. Oops, where am I going? There. Okay. So, a lot of difference here. The difference here is this was compiled with optimization, further optimization, and best. Now, if we look at the code compared to the second one, no longer are we comparing EBX against 8, and no longer are we starting at 0. And we also aren't doing this outside call. Now we're starting with EBX at 8 every time it starts, it decrements and jumps if not signed, because it's quicker, it takes up less space. And instead of moving a string or putting this up at the top of the stack and calling put char inside my program, it calls it directly within MSBCRT. And then it decrements EBX, and once it's at -1, it's going to jump. It's not going to jump, it's going to come out. Then the next one is exactly the same. We see that the only time we don't see this decrement EBX, jump if not signed, is when we want to stop at 0. Well, number 3 is start at 9, as long as we're greater than 0, print 3. So that's what this says. Move EBX 9, start at 9, as long as we're greater than 0, print 3. This could be written differently. We could start at 8 and go till -1. It's the same number of times. And it takes up that much less space. But it would work exactly the same. But since our code specifically said to start at 9, it didn't make that change. And then we see that it does some funkiness where it moves EBX 9 and then jumps to the beginning of it instead of just starting right here. I don't know why, but it decided to do that. Again, we see put char 4 while we are not negative. We started at 9. We start at 8 while we're not negative. Okay, so the first do while is number 9. That's what I thought. Let's go down to 9 and see if it looks any different. Move EBX8, jump mouse sign. It doesn't look any different because all of these are actually written in a quote do while format, and that's just to save space. So there's many different ways to write the same exact C code in assembly. It's just knowing what to look for. This is the same as this, which is also the same as this. They might look different, but in the end, they do exactly the same thing. It's just how many bytes they use, how much space is wasted, and how quick and efficient it is. That's what the compiler does for you. It takes our nice and neat, easy to read code and turns it into code that the processor can actually use. It turns it into these little bytes over here. And depending on the level of optimization we want, determines how in depth it goes and how much it thinks about what it's going to actually turn it into. Is it going to take the easiest route and give you something like this? Is it going to take the next easiest route and give you something like this? Or is it going to think hard, the hardest route, but best payoff, and give you something that's quick, efficient, takes up less space, like this? So that's the video for today. I'm working on a couple other videos. I wanted to get this one up because I find it really interesting, and I hope you guys do too. Thank you for watching. Please rate, comment, and subscribe. You know, do that thumbs up thing. I'm going to try and get another video out this week, but if I don't, I'm sorry. Thanks for watching.